Okay, so now that we have our cube, I am going to have to introduce, of course, we were actually supposed to have a rotating cube, so in order for us to rotate the cube, we need to add some of the graph functions linked to the mouse. So first, I'm just gonna come here and introduce variables. So I'm gonna int two new variables. So I'm just gonna call it last x and assign it 0, and I'm just gonna copy paste this for y, call it last y. And of course, for the rotation, I'll call it rotate x, assign it 0, and copy paste the same for y. Okay, so these variables I've declared are the ones which I'm actually going to be using in the functions which I'm going to define below. So I hope you're still following. So I'm just going to drag down and write them after so that we make sure the blocks of code are almost the same as they were. So right here, we're going to add a comment section for the mouse rotation. And of course, so GL rotate F is actually the function which you're going to be using. Of course, rotate X, that is the variable we had declared earlier on, and set it to 0. So as you can see, the function actually rotate X. You see, we have written 1, 0, 0. The 1 actually stands for rotation on the x-axis. The following 0 is on the y, and the following is for the z-axis. So after copy pasting for the y, sorry, it's supposed to be a 1, not y. So yeah, so the first one is actually going to be rotation on the x-axis, and the second is going to be rotation on the y-axis. That's why it's 1, 0, 0 and 0, 1, 0 using the GL rotate F function. So that is actually the GL function which allows for rotation. Then we're going to specify another function. I'm just going to call it mouse, and I'm going to pass int button and int state, and of course you're going to int x and int y. So with this function, we actually want to check whether the mouse has been clicked, and the last x variable is actually going to be stored in the coordinate of x, same with the last y. So what we're going to do is we're going to implement a loop to check whether the mouse button has been clicked. So we want to check when the guy clicks the button on the mouse, the left hand button, whether it will actually rotate the output on the screen. So if the button is equals to left button, so if you click on the left button of the mouse, actually, whether we are going to rotate the output. So as you can see, the GLAD library comes with these inbuilt functions. When you type them, they will autofill, though you might have to research a bit on what does what. So if you click on the button, it will actually take the coordinates of the x and place them in the last x variable which we declared, and same on the y axis. Sorry. And then we are going to introduce another function, and I'm going just to call it void motion. So we're going to be passing the int x and int y. So rotate x, this is where it will come in handy. So remember, the last x stores the current x coordinate of the mouse variable, but when we do rotate x, we want to increment it onto the difference between the current coordinate of y and the previous y coordinate. So the movement on the y axis by the mouse is going to be used to control rotation on the x axis, and the same with the movement on the x axis, sorry, is going to be used to control rotation on the y axis. So basically, when we have written rotate x plus equals y minus last y, that's what we're doing. We're adding the difference between the current y coordinate and the previous y coordinate so that you can rotate the mouse around the x-axis. The same happens for rotate y plus equals x minus last x for rotation around the y-axis, and the last x stores the current x coordinate of the mouse variable, and the last y stores the current y coordinate. Of course, GLUT post display is going to post a request to redraw the display after the rotation of the output. So I'm just gonna build this, and no errors as you can see, and when I run it, okay, output, yep, there we go, we have our cube. And you can see when I drag, after left clicking, you can see we can be able to see the cube. You can see actually it moving from side to side, top to bottom. Then I left click and drag along, you can see the cube is moving. So you can actually see the 6 faces of the cube.